Okay, good morning to everybody. Thank you to Manu for this kind of invitation. Well, I'm not a fanatic. I don't have any conflict of interest for this, and I didn't marry albumin or starches and so on. But just few consideration. Sometimes, any times I heard about fluids, it seems really a religious battle because it's not true or not true, but believers and not believers. And I think the albumin is a classical example. Well, I will present data without many comments, and I think the non-believers will be happy, and the believers will be happy. So, just look, and this paper is under review, it's quite advanced, under review. I think it will be published quite soon in a major journal. Anyway, the albumin. Well, let's see that I perfectly agree with Perel about the medical reasoning. To me, the evidence-based medicine is the killing of the medical reasoning. Why should I know how the electricity works if I push the light? Why should I know the mechanism? Unfortunately, in very few are evidence. And albumin is an interesting molecule because he has a lot of things. He has oncotic pressure, and this is referred to when we speak about the fluid replacement. So the albumin stay in the blood compartment, not in the interstitium, so and so. So everybody knows about this is very scholastic and schematic and very often untrue statement. But we have other function on binding and transport. We have anti-inflammatory effects. Is a major antioxidant, and it helps on the endothelial stabilization, some anti-aggregant factor, and is the major factor for the acid-base equilibrium buffering in the interstitial space. So what I will present is more than volume replacement, is the albumin replacement. Because you know that if you take the literature, if you take Cochrane, you read that albumin killed the patient. Then you have other meta-analysis and a few other papers where albumin is of benefit. Then we have other papers other meta-analysis saying albumin is indifferent. Personally, I hate the meta-analysis, but anyway. So we decided to do one study about the albumin supplementation. Was not funded by the industry, so no one patient, no one doctor took €1 or $1 for that. Was in part a very small funding from the government, from Italian government. And we enrolled a patient with severe sepsis according to the usual standard, or septic shock. Means a patient with severe sepsis, but a cardiovascular suffer of 3 and 4. Then we had the randomization process, and we had the volume replacement more or less according to the river protocol. So we have a target. We are not religions of river. By the way, 10 years before river, we did in 1,000 patients 70% SVO2 target. We couldn't find one death of difference in the study. Anyway, it sounds reasonable. Target, and the group A was treated with albumin, 60 grams, so 300 grams plus crystalloids, of course, not only albumin. What is important, the total volume in this phase. And the other group, just with the crystalloids. We could not oblige to use one kind of crystalloid. So either we have a ringer lactate or a saline, whatever crystalloid that people wanted to use. And from day 1 to 28, this was done on the day 1. In the day 2, if the patient with albumin had in the albumin group had less than 30 grams, greater than 30 grams per liter, no albumin. If they were below this threshold, because this was taken from the Dubois and Jean-Louis Vincent study, saying, okay, if you maintain albumin greater than 30, is a good thing in terms of organ improvement and so on. So we tested also this hypothesis. And below 25, we had infusion, big infusion of albumin. This on the day from 1 to 28 up to the discharge. This is the enrollment, and we had a quite good enrollment. The participating center was done exclusively in Italy. Most are in the north of Italy, but we got 100 units. So it's a very, now is fashion to call it pragmatic trial. I do not know of any theoretical trial, but this is the name which is, so this was a pragmatic trial, 100 units. And you see, we had enrolled 1,300. In our initial protocol, we specified that our goal at the beginning was 1,300, but we specify if the committee, the review committee, will tell us, maybe you are close to some results, go ahead, we were available to go up to 1,800. After the first review, after the first interim analysis, the committee say, okay, go ahead until 1,800. So this was the division of the patient. At the end, we had 903 patients were analyzed in a patient with in albumin group, and 907 in a patient without albumin. And we're quite proud, not proud. It happens that the follow-up was quite good, because at the follow-up we lost really very few patients, about 14 patients per group. So at the end, for the analysis at the 90 days, 888 and 893. I cannot leave these slides because there is the usual story of the embargo for the journals before publication. So anyway, these are the numbers. And I don't want to bother you with a series of tables of the baseline characteristics. The randomization works quite well, and the patient was very comparable for age, for SAPS, for site of infection, and for physiological variables, as the acid-base status, mineral weight pressure, heart rate, and so on and so on. And we have, this is interesting, severe sepsis, where 675 patients, and patients with septic shock, there were 1,000. The mortality of these two groups taken together was quite different. We had 34 versus 46 patients. This is the mortality of severe sepsis, and we specified when we sent a protocol to the US government that severe sepsis and septic shock, but we didn't think to randomize the patient, to stratify according to the severity. Don't ask me why, because it was so natural. Okay, you have severe sepsis and septic shock. There are two different things, or 2 degrees of the same thing. We stratified for the time of admission. So between 6 hours and between 12 hours after the diagnosis, or 24 hours after the diagnosis of sepsis. This is the organ dysfunction, which come out to be significantly different. To me, it's very hard to understand where, clinically speaking, there is an imbalance between the two groups. And these are some of the results. This is first the serum albumin. You see, we start with 23, 24, which is typical of patient in intensive care. But almost just after 1 day or 2 days, we were close to the target, which was around. So we had a very good separation between the group treated with albumin and the group without albumin. And these very few physiological variables. Well, let me specify. The total amount of fluid at the beginning, day one, was exactly the same in the two groups. Was 4.5 liters or something like that, and I have a slide, in the group with albumin, and 4.5 liters in the group without albumin. Total amount counting also the fluid given to give the antibiotics, to dissolve the drugs, and so on. Okay, so the story, remember these were patients with sepsis, which are supposed to have some capillary leak problem. Anyway, despite at the same amount of total fluid with albumin or non-albumin, it happens that the mean airway pressure was significantly greater in the albumin group, but you see, we have a very large standard deviation. The mean are 2, 3, 4 millimeters of mercury difference, and nothing particularly exciting. The central venous pressure was greater for the same fluid in the albumin group, despite, I remind you, at the beginning, our target were equal for the two groups. And I think it's quite interesting that the group with albumin reached the zero balance of fluid earlier than the group with no albumin. So that means we have more negative or less positive fluid balance in a patient with albumin. This is the 90 days mortality for the overall population at 90 days. And you can see the mortality is 41 versus 43, which is not significant in this with this size of population. So the people who hate albumin say, yahoo, I always tell you. Now, these are the patients with septic shock as defined according to the SOFA score. We have 1,300 patients total, and you can see that it happens that at 90 days the mortality results lower in patients with about 6% of difference in the patient who were treated with albumin. Not only resuscitated with albumin, treated for 28 days with albumin. This is the forest plot of the system. You can see this is the total population. And look here, this is quite curious. The early versus the more late start of the treatment. And you see that with the early patient, we couldn't find a difference. And this was exactly the contrary of what we expect. But the patients who were treated not after the 6 hours were more severe. So have an overall greater SOFA and so on than the patient without. And you see here is the subgroup analysis. Now, let me concentrate in the subgroup analysis, but the groups were very well balanced, but not randomized. The severe versus not severe. This is the subgroup analysis of the patient with septic shock. So only the patient with septic shock. And you can see we have 565 and 570, so we're very balanced the group. Well, basically we found the same thing that we found in terms of physiological variables that we found in the general population, but at greater extent. So we have a greater differences, as an example, in millimeters of mercury of pressure, in greater differences in these physiological variables. And this is the 90 days mortality of the patient with septic shock And you can see once again, at the 90-day, we had advantages in terms of mortality, and we were close, no, we were significant. Also, the patient treated after 6 hours, having the septic shock, so which were the patient more severe, had advantages in terms within the septic shock group, and advantages with albumin. So we have more and more data saying that the more severe is the condition of the patient in terms of physiological variables, let's see. And this, I think, is quite interesting. These are the patient with the pressure. The patient came because the patient was treated with having septic shock, was classified also the patient with high dosage of dopamine or noradrenaline. And you see that the patient in which the pressure was lower than 70, the patient with septic shock, but septic shock plus some real sign of hypotension, had a significantly greater mortality than the patient without. And you have all the tendency of the patient with this is also interesting. We have to look, to analyze more strictly this data. But if we look at this slide, this is according to the time. You see, if we divide the patient, this is, of course, the problem, the subgroup analysis, but I think it's quite interesting. If we divide the patient in which the length of stay was quite short, we have advantage of albumin. In the mean length of stay, patient, no difference. In the patient who stayed longer, we have a trend toward to have an advantage in the patient treated with albumin. Has this something to do with the fluid resuscitation during shock? Has this something to do with the albumin supplementation during all period? I don't know. But these are the numbers we get. So I think in the major journal, the conclusion will be intention to treat in the overall population, no benefit of albumin. That's it. If you read only the conclusion of the author, you say, out. If you read the paper, you can start to think. My personal conclusion that I use conclude this one: if my brother would have a septic shock, I would give albumin. I thank you for the attention.